Hello everyone, how are you all? In today's video, we'll be learning second chapter of chemistry, which is matter around us pure? Okay, so in this chapter we'll be mainly studying like what is matter, what exactly it is, its classification. Okay, we'll be studying all its classification in detail and also the separation techniques. Okay, yes. Let's start without wasting time. So have you ever noticed the word pure written on few consumables like milk, ghee, or salt, right? So if we ask for a common person or according to a common person, pure substances means like without no adulteration, right? But for a scientist, these pure substances like milk or ghee, actually these all are impure substances according to the scientist. Okay, if a scientist is saying that a substance is pure, which means, or it means that all the individual constituent of that particular substances are of similar type or of same type. Okay, and they all have got same chemical nature. Okay, so this is what he means a pure substance. Okay, but according to a common person, I told if it is not having any sort of adulteration in it, he called that as a pure substance. So the answer for our chapter title, is matter around us pure, is no, right? So few are pure and few will be impure substances. So now let us study about these pure and impure substances in detail without wasting time. Okay. This is how the matter has been classified. Okay, so before that, let us know what exactly the matter is. The matter is nothing but it's a substance which occupies space and has mass. Okay, for example, table, chair, okay, or whatever the substances which you see in your day-to-day life, or example hair, right? So that also has a mass, it occupies space, right? So all these substances which has got mass, and if it is occupying a space, we call it as a matter. Okay, so this matter we have broadly classified into two types. One is pure substances, another one is impure substances. Okay, so again the pure substances we have classified them into two types. One is elements, another one is compounds. Okay, these elements again can be further divided into metals, non-metals and metalloids. Okay, is that clear? So now in the impure substances, okay, impure substances we have got mixtures, and again this mixtures can be classified into homogeneous mixtures and heterogeneous mixtures. Okay, so homogeneous mixture will be studying about solution, or you can even call it as a true solution and alloy. And then in a heterogeneous mixture we'll be studying the suspension and colloid. Okay, so this is all about the classification of this matter. So now let us understand what are pure substances. Fine. So pure substances are those, as I already mentioned before, these are the substances, okay, which are made up of same kind of individual particles. Okay, and all these individual particles of these pure substances will having same chemical nature. Okay, for example, copper, okay, or iron, or water, these are all examples for pure substances. So now let us understand what are elements and what are compounds. So elements are the pure substances which are made up of same kind of atoms. Okay, and they cannot be further divided or they cannot be further broken down into simpler particles. Okay, for example, copper or iron. Suppose if I am taking a copper sheet, okay, and if I am trying to cut them into smaller and smaller pieces, or these individual smaller pieces will also consist of copper atoms, right? Copper atoms. Even if I am trying to separate them, you are not able to what? Break down into again simpler particles, right? Again the small sheet of this copper also contains the copper atoms. That is why we tell that the element cannot be further divided into or broken down into simpler particles. And till now we have got 118 number of elements in nature, okay, and these 118 elements, okay, we have classified them into these three types, which I have already told, that metals, non-metals and metalloids. Okay, so now let us understand each and every properties of these metals, non-metals and metalloids. Okay. So metals usually show these many properties. Okay, so the metals are lustrous, they show the property of lustrous, which means they have got a shiny surfaces, they shine. Okay, for example gold or silver, they shine, right? So that property we call it as a lustrous. Okay, and then they are sonorous. Okay, they make sound. Suppose if an iron is falling down, okay, it makes sound, right? So this property we call it as a sonorous. Okay, and the metals show a property of malleable. So malleable is the property where the metals can be hammered into thin sheets. Okay, so that property we call it as a malleable. And then they are ductile, which means the metals can be drawn out into a wires, thin wires. Okay, and then these metals are a good conductors of heat and electricity, right? And you already know that. And these metals, they usually remains in a solid state at a room temperature. For example copper, silver or iron, right? You might have seen all remains in a solid state itself, correct? So other than exception is there, which is mercury, it usually remains in liquid state, right? So these are the physical properties which are exhibited by your metals. Okay, so coming to the non-metals, this non-metals will not show any of these properties. They are non-sonorous, they are non-lustrous, they do not shine, right? For example, oxygen you can take, nitrogen you can take, carbon you can take, right? So do they make sound? No, right? So they are non-sonorous, they are non-malleable, they cannot be hammered into thin sheets, and they are non-ductile. You cannot draw them, or you cannot draw them into very thin wires. Non-metals are very bad conductors of heat and electricity. Again we have an exception over here, which is nothing but a graphite. Okay, so the graphite is a very good conductor of electricity. Okay, it's an allotrope of carbon. Because of its structure, it can conduct an electricity. So these are all the physical properties which are exhibited by the non-metals. Fine, yeah. So now coming to the metalloids. See, metalloids are those which will show the intermediate properties between metals and non-metals. Okay, and examples for metalloids are germanium, okay, boron and silicon. Okay, these are all the examples for metalloids. Okay, yes, so this is all about elements classification. So now let us study about compounds. What are compounds? I told that elements are pure substances which are made up of same type of atoms, right? So compounds are also pure substances, okay, which are made up of same kind of molecules, or you can even tell that compounds are pure substances which are made up of two or more different types of elements, right? Internal element is also a pure substances. That's why we bring these compounds under pure substances. So now let us understand the few properties which are exhibited by the compounds. Okay? So these are the few properties which are exhibited by the compounds. Okay, so for compounds you can give an example of water. Okay, and element you already know that, few examples like oxygen or nitrogen. So the first point is telling that two or more elements will combine together to form a compound, right? So that is what definition of compound is, right? And then the composition of each substance is fixed. So what is this? Composition of each substance is fixed. So you can see the example we have taken as a water itself, right? So here you can see that hydrogen and oxygen, right, both are different elements, and these are combined together to form a water molecule, right? So this is nothing but an example for a compound. So here you can see that H2O, we have taken it as an example for compounds, right? So H2O, it is a combination of two different elements, which is hydrogen and oxygen, right? And this hydrogen, okay, has got two atoms, and oxygen, it has one atom, right? So two atoms of hydrogen and one atom of oxygen are combining together to form a water molecule, right? And also, if you are considering in terms of mass, this hydrogen and oxygen will always combine in 1:8 ratio to form one water molecule, right? You already know that hydrogen have got a mass, right? Atomic mass of 1 AMU, right? And oxygen, how much it is? 16, correct? So, but we have two atoms of hydrogen, right? So 1 into 2 is 2. So how we can write this? Like 2:16, but we can simplify it, right? So 1:2, 2 ones are and 2 eights are. So thus I told that hydrogen and oxygen will combine in 1:8 ratio, like 1 gram of hydrogen will combine with 8 gram of oxygen to form water. Okay, so you can see that their ratios are fixed. So that is what the second property means. Okay, so the third property is the compounds will exhibit different properties from that of its individual constituents. So we can take again the example of water itself. Okay, so water is made up of hydrogen and oxygen, right? So if we see the property or the one of the property which is exhibited by hydrogen is this: hydrogen is a combustible gas and oxygen, okay, it is a combustible gas, and oxygen itself, it's a supporter of combustion, right? It supports a combustion, which means if somewhere if fire would have been caught, so if there is a supply of oxygen, what happens? It increases more, right? But the compound, right, but a substance which is formed by the combination of hydrogen and oxygen is nothing but a water, it will extinguish that fire, right? So you can see that the property which is exhibited by the compound is totally different from that of its individual constituent elements. Got it? Okay, so this is all about the third property. Okay, and the last property is that the constituents of these compounds can be separated only by means of chemical methods. Okay, see, water again we can take. Okay, if I will be having one bottle of water over here. Okay, so for example, I'm having one bottle of water here. So if someone asks me to separate oxygen gas or a nitrogen gas out of it, will I be able to do? No, right? I can't do it by any means of physical methods. I can't do it. Okay, so this hydrogen and oxygen can be separated only by means of chemical methods. So we have something called electrolysis process. Through that we can separate hydrogen and oxygen gas from the water. Okay, is that clear? So these are all the few properties which are exhibited by the compounds. Okay, so shall we go forward for the next topics? Yes, which is nothing but impure substances. We will study that also in depth. So now coming to the impure substance classification. So now so far we studied about pure substance classification, right? So we covered like element, compound, and the properties of the elements in turn, like metals, non-metals, and metalloids. Right, so now we'll be studying about impure substances. As I already told, impure substances are those which are made up of two or more different types of substances. Okay, so now in that we have mixtures. Okay, again it can be classified into homogeneous and heterogeneous mixtures. Okay, so coming to this mixture, what is mixture then? Right, so mixture is nothing but it is a impure substance where it is made up of two or more different types of substances in any ratio. It's not like that of compound that the the constituent particles should be in fixed ratio. It can be in any ratio in the mixture, right? For example, sugar solution or a salt solution or a mixture of sand and water, all these things you can consider it as an example for mixtures, right? See, I can take 1 glass of water, right, and I can even put 100 gram of sugar in it or 500 gram of sugar in it. It's up to me, right? It's not like it is there in a fixed ratio. It can be in any ratio. So these are mixtures, and more importantly, these mixtures, right, you can separate the constituent particles. You can separate by means of physical methods itself. Okay, for example, if I am taking a sugar solution, right, or a salt solution, which is a mixture of salt and water. So how can I separate a salt from that water? Just by evaporation process you can do that, right? Just start boiling that mixture. What happens? All the water particles will evaporate and salt will be remaining in the vessel, right? So this is how, by means of physical methods itself, you will be able to separate its constituents, unlike compounds where only what? Chemical methods has to be applied in order to separate its individual components. Is that clear? Fine. So again, this mixtures, I told you already, homogeneous and heterogeneous. This is what the classification we have. So now let us study about this homogeneous mixture. So what is this homogeneous mixture? Yes, again it is nothing but it's a combination or it's a mixture of two or more substances. But the thing is, here those particles will be thoroughly mixed that you cannot differentiate between those particles. For example, sugar solution itself or a salt solution itself. When you dissolve a salt in a water, will you be able to see the salt particles, or will you be able to differentiate between the salt and a water particle? No, right? You can't do that because it has been thoroughly mixed. It has been evenly distributed. Okay, this, the salt particles have been evenly distributed throughout this water solution. Okay, so that's why we call such solutions as homogeneous mixtures. See, homo always refers to what? Same, right? Same genus. Genus means phase. So they all are remaining in a same phase. Okay, yes. So in homogeneous mixture, we have something called a solution or a true solution, you can tell, and a alloy. I'll talk about it later. So now coming to a solution. Solution is nothing but it's a combination of solute and solvent. Okay, so solute is nothing but it is a component which will get dissolved in a solvent. Okay, and solvent is a substance which will allow the solute to get dissolved in it, or which will dissolve the solute particle. You will call that as a solvent. Okay, for example, which we are so much familiar with, nothing but a sugar solution you can take. In that, sugar will act as a solute. It's a component which is gonna dissolve in this solvent, right? And the solvent is nothing but what? Water. Correct. So the water is making the sugar to get dissolved in it, right? So this we call it, or together what it makes? It makes a sugar solution. Okay, so now you can see here we have few examples of solution like sugar and water, which will make a sugar solution, right, or a salt solution. And also we have a notion that solution means it is always liquid. No, nothing like that. Okay, so solution basically I told you, right, it is a homogeneous mixture where both the solute and solvent will be in a same phase. Okay, you cannot differentiate between a solute and solvent. That's all. It can be either solid, liquid or a gas. Okay, you can see this example of aerated drinks, right, where CO2 is acting as a solute. Okay, it is being dissolved in a water. You can see soda water and all. So this CO2 will be dissolved in this water. So this is also a solution, right? And also you can see this hair, right, which is nothing but a true solution, okay, of gas. Okay, here the solute is also a gas and the solvent is also a gas. It's that the gas is, so here is nothing but what? It's a mixture of gases, right? You can encounter oxygen, nitrogen, many other gases in the hair, right? So it is gas in gas. So solute is also a gas and the solvent is also a gas. Okay, and tincture of iodine, you can see iodine, which is nothing but a solid component like your sugar or salt, that is also a solid, right? But instead of water, okay, instead of using water as a solvent, we are using a alcohol. So if iodine is getting dissolved in alcohol, we call it as a tincture of iodine. This is also one of the examples for the solution. Okay, understood, right? So this is all about a solution. So now let us understand what are these alloys. Okay, so alloys are also a homogeneous mixture of metals, right, of two metals or a metal and a non-metal. Okay, so that mixture of either two metals or two or more metals or a metal and a non-metal, we call it as an alloy. For example, you can see brass or stainless steel. You can consider many more examples for alloys. Here you can see that brass over here, it's a mixture of copper metal and a zinc metal. So what they are doing is they are taking copper, okay, its molten form. So 70%, in 70% of copper they are adding zinc. Okay, they are adding 30% of zinc, which will in turn give you a brass. Okay, so this is all about alloys. So now coming to the properties of a solution, you can see that I have written few of the points, right? So the first one is that the solution is a homogeneous mixture, right? And then if we see the particle size of a solution, it is very much lesser than 1 nanometer. So if we see the particle size in the solution, it is lesser than 1 nanometer, which is nothing but 10 to the power of minus 9 meter. Okay, so the particle size is very small that they do not scatter a beam of light if it is passing through it. Okay, and hence the path of light will not be visible. Suppose what happens, consider if I am consider I am taking a glass of water, okay, and I am dissolving what? Salt or a sugar in it. So the particles are very small, okay, you cannot differentiate between water and a salt particle here, right? So when I pass, okay, when I pass a beam of light through it, do you think that these particles will scatter the light or the path is visible? You can even do this experiment at your home. Okay, so this property of scattering a light is not possible from this solution. Okay, and next is the filtration. We cannot separate the constituents of this solution through the process of filtration. Can you separate the mixture of salt and water through filtered paper? No, right? You cannot do that. So we cannot use filtration process to separate the individual particles. Okay, and then this solution is a stable, which means that the particles or the solute particles in the solution will not settle down after some time, right? Have you ever seen sugar or a salt particles getting settled or coming down in the bottom of your vessel or a glass? Right? No, it won't happen, right? Thus we can tell that a solution is a stable mixture. Okay, so this is all about the properties of a solution. So now let us understand the properties of the heterogeneous solution, okay, and its classification. So now coming to the heterogeneous mixture, right? So it is a mixture where the components of it are not uniformly distributed throughout the mixture, okay, and it can be easily differentiable. For example, the mixture of sand and water, or oil and water, right, or milk. These are all examples for heterogeneous mixture. See, in sand and water, if you are putting a sand into water, you can easily differentiate, right, between a sand particles and a water, correct? And if you are mixing oil and water, you will be able to differentiate between oil and water, correct? And milk, for naked eyes it looks like a homogeneous, but exactly not. When seen under microscope, the milk has got many particles like a fat, protein are suspended in water solvent in a milk. So for us it looks like homogeneous, but exactly it is not. It is a heterogeneous mixture. And also blood is also an example for heterogeneous mixture. Okay, so this is all about the heterogeneous mixture, and again we further divide this heterogeneous mixture into two types, which is suspension, another one is colloidal solution or a colloids. Okay, so now let us study what is suspension and its properties and also examples of it. So now coming to the definition of suspension. Suspension is a heterogeneous mixture where its solute particles will not get dissolved in a solvent. Instead, they remain suspended throughout the bulk of the solvent. Okay, so this is what suspension is. For example, you can take a mixture of sand and water or a oil and water. Okay, so these are all the examples for suspension. Okay, so let us study the properties of the suspension. Okay, so yes, coming to the particle size of the suspension, right, it can be seen by our naked eyes too, right? If I take a solution or a heterogeneous mixture of these two things, sand and water or oil and water, you can easily see sand through your naked eyes, and oil you can easily differentiate, right, between a sand and a water particle and a oil and a water particles, right? So the solute particles can be easily seen through our naked eyes. And next is the scatter beam of light. You can see this is very important only in their disturbed, only when they are in disturbed state. Okay, I'll tell you that. Yes, so I told you that these particle size are big, that you can see through your naked eyes. So they are big enough to scatter a beam of light which is passing through it. Okay, and thus the path of light is visible, but this happens only when they are in disturbed state. Okay, see what happens if it is undisturbed, all these particles will go and settle. For example, sand particles, if you after some time, what happens, it all the sand particles will go and settle in the bottom of this particular glass or vessel, whatever you had put in, correct? So only in its disturbed state it can scatter a beam of light, else it is not capable of scattering a light which passes through it. Okay, and yes, as I told you, it is unstable because after some time all these particles, all the solute particles of a suspension will suspend or will go and settle down, so it is unstable. And yes, we can separate this constituent particles. So we can separate a solute from its solvent through the process of filtration. Okay, because the particles are large enough to get caught by the filtration distillated paper. Okay, so these are all the properties of a suspension, right? You understood, right? What is a suspension? Its examples, the properties. Fine. So shall we go to the next kind of heterogeneous mixture, which is a colloid? Yes, so now coming to the colloids or a colloidal solution. The colloidal solution is a heterogeneous mixture where the particles are somewhat uniformly distributed. But you know, due to the very relatively smaller size of particles than in the comparison with the suspension, it looks like homogeneous mixture. But exactly it is not. I told you, right? The example of milk and blood, these are all examples of a colloidal solution. Okay, so it looks like a homogeneous mixture, but it is not. Okay, because of very relatively smaller size of particles than that of suspension, it looks like a homogeneous mixture. Okay, and thus they are very small enough that you cannot see with the help of your naked eyes. Okay, so the second property is that the scatter a beam of light. Okay, when a beam of light is passed through a colloidal solution, it scatters it and makes the path visible. Okay, so this effect only we call it as a Tyndall effect. Okay, so what is Tyndall effect? It's a phenomenon wherein which the colloidal solution are scattering a beam of light and they are making a path visible. Okay, and this is named after a scientist, Tyndall. Fine. So next is that these colloids are quite stable. It's that the particles of these colloid will not get settled down when left undisturbed. So we can call it as a quite stable. Fine. And then filtration process. No, we cannot separate the constituent particles of the colloids through the process of filtration. Okay, it can be separated with a process called centrifugation, and this like how it is, on what principle this will work, we will study it in detail in the next video. Fine. So these are all the properties of a colloid or a colloidal solution. So coming to this Tyndall effect examples, this Tyndall effect can also be observed like when a beam of light passes through some holes in your rooms, you can see the path of light. Okay, so that's because of the dust and the smoke particles will scatter this beam of light which is entering through that hole in your room. Okay, so this Tyndall effect can also be observed when a sunlight passes through a canopy of a dense forest. So what happens there is the water molecules which are present in an atmosphere or a fog or mist particles, they will scatter a beam of light. Okay, so this is all about the Tyndall effect examples that you can see. Okay, fine. So now let us understand the components of the colloidal solution. Okay. Yes, so the components of the colloidal solution are dispersed phase and a dispersion medium. So what is this dispersed phase? So dispersed phase is nothing but it's a solute-like component in a colloidal solution, and a dispersion medium is a solvent-like component of a colloidal solution. Okay, instead of using terms like solute and solvent, we use a dispersed phase and a dispersion medium with respect to the colloidal solution. Okay, and again based on the types of dispersed phase and dispersion medium, like a solid, liquid, or whether it is a gaseous state, we have different types of colloidal solution. Okay, so depending on the types of dispersed and dispersion medium, whether it is a solid, liquid, or gaseous states, we have different types of colloidal solutions, right? So if it is dispersed phase is a liquid and a dispersion medium is a solid, we call that as a gel. Example is jelly, cheese, okay, etc. And if a dispersed phase is a gas, dispersed phase is nothing but a solute-like component, and if a dispersion medium is a solid, we will call that as a foam. Example is your rubber, sponge, okay. And there is something called emulsion type, where dispersed and dispersion medium both are liquid, okay. Example is the milk, face cream. These are all the example for emulsions, and we have many more types like aerosol, solid sol, and sol. So this is all about colloids. Fine. So now let us understand about a concentration of a solution, and also we will try to, and we'll also solve a problem on it. Okay. Yes. So now coming to the concentration of a solution, let us understand what is dilute or what is concentrated solution. Okay. So depending upon the amount of solute present in a solution, we call that as either a dilute solution or a concentrated solution. Okay, if the amount of solute present in the solution is less, you call it as a dilute solution. And if an amount of solute which is present in a solution is relatively more, okay, you call it as a concentrated solution. Okay, so this dilute and concentrated are a comparative terms. Okay, so if a solute is having relatively lesser amount of solute, you call it as a dilute, and if it is more, you call it as a concentrated. Got it? Fine. So now what is the saturated solution or a unsaturated solution? For this, to understand, they have given an activity in your textbook. So what they are telling is, they are telling you to take 2 beakers of 50 ml of water, and they are asking you to dissolve a salt in one beaker, name it as A, and in another they are telling you to either dissolve sugar or a barium chloride. Okay, and now you can call it as a beaker B. Okay, they are asking you to dissolve a salt and sugar, okay, and keep on adding. When it stops, okay, when these solute stops dissolving in it, you can start heating up, okay, you can rise the temperature up to 5 degrees Celsius, up to 5 degrees Celsius in both the beakers, and you can start adding these salt and sugar again in these 2 beakers. So what happens, I could tell that the concentration or the amount of salt and sugar or a barium chloride which gets dissolved in this water won't be same. Okay, so with respect to this, we can understand these 3 terms very easily. So what is saturated solution? Okay, it's a state of a solution where a solution is not capable of dissolving more solute in it at a given temperature. Okay, so now coming to the unsaturated solution. So this is a solution wherein which it can dissolve more amount of solute in it, or you can even call this as a solution where it is containing a solute which is lesser than a saturated solution. Getting right? So this contains a solute which is having a lesser amount of solute than a saturated solution, because when it reaches the saturated state, it cannot dissolve more solute in it anymore. Okay, so this is about saturated and unsaturated. And what is the solubility? The solubility is nothing but it is the amount of solute which is present in a saturated solution at a given temperature. Okay, so this is all about these terms. Fine. So now let us try to understand what is concentration of solution, and we will solve one problem on it. Okay. Yes, so we can define a concentration of solution as the amount of solute which is dissolved in a given amount of a solution or a solvent. Okay, and we can express this concentration of a solution in 2 ways. So one is by mass method or a mass by volume method. Okay, so in mass by mass method, what we are doing is we are calculating the mass of the solute to the mass of the solution. Okay, but here in mass by volume we are calculating with respect to mass and volume, like a mass of solute to a given amount of volume of a solution. Okay, so these are the two ways in which we will be calculating the concentration of a solution. Okay, so understand this, we shall solve a problem. Yes, so this is how the problem statement looks like. A solution contains 40 gram of common salt in 320 gram of water. So calculate the concentration in terms of mass by mass percentage of the solution. Okay, so from this what and all can you infer? You can see that 40 gram of common salt, which is nothing but a solute, right? So the mass of the solute is 40 gram, right? And what is the mass of the solvent? Mass of water, you can see that it is 320 gram, right? See, 320 gram of solvent. So now we already know that a mass of solution or a mass percentage of solution is mass of solute to the mass of solution, right, into 100. This is how we get the mass percentage of solution. So we already have a mass of solute which is 40 gram, but we want a mass of solution. Do we have that here? No, right? So we have to find it out. How do we do that? It's as simple as that. No, we know that mass of solute plus mass of solvent will give you what? Mass of solution, right? So 40 plus 320, how much it is? It is 360 gram. Right, so we got the mass of solution also. So just substitute over here, you will get the answer. So mass of solute is how much? 40 gram. So 40, and mass of solution is what? You got by combining the mass of solute and solvent, which is 360, right, into 100. So how much it is? Right, so 1 by 9, it will be like 11.1%. So the mass percentage of solution is 11.1%. Okay, so this is how the same way you can solve the multiple problems. Okay, yes. So now let us go to the next topic, which is separation techniques. Okay, so different methods are used in our day-to-day life in order to separate the individual components from the mixtures, right? So you must have seen hand picking, sieving, or doing filtration. These are the separation techniques which you encounter in your life, correct? So sometimes it's necessary to use special techniques in order to separate the individual components from its mixture, right? So which are all those special techniques? Yes, we have evaporation, centrifugation, sublimation, and we use separating funnel and chromatography technique, and distillation, fractional distillation, and crystallization methods to separate the individual components from the mixture. Okay, so now let us discuss about each and every technique one by one. Fine. So now let us discuss about our first separation technique, which is evaporation. Okay, so I'm pretty sure by this time many of you would have been knowing about evaporation, right? So before that, let me tell you when we can use this process of evaporation. Okay, so when your mixture, when it is made up of a solid solute, okay, which is dissolved in a liquid, which means it is your solvent, right? So in this case, if your liquid or a solvent, if it is volatile, okay, and if your solute component is non-volatile, then you can use the process of evaporation to separate a solute from its solvent. Okay, so before that, what is the meaning of this volatile then? right? So volatile is nothing but it's a chemical component where it can be easily converted into its vapor form. Okay, for example water, right? When you heat it or when you boil it, what happens? It converts from liquid state to its vapor state. So you can give an example of water for a volatile compound, right? So there are few components which are volatile even at the room temperature. Okay, for example acetone, it converts into vapor state even at the room temperature. Okay, so we understood, right? So when we have a solute which is non-volatile and a solvent which is volatile, then we can apply this evaporation technique to separate the individual components of the mixture. Okay, so now let us take some example to understand this. See here, there is a mixture of salt solution, okay, which means a salt is used as a solute and a water, right, is used as a solvent, correct? So this is a salt solutions what we have taken in a beaker. Now we have to separate salt from its solvent, which is water, right? So how do you do it? You have to just supply the heat, and then what happens? It starts boiling, the water starts boiling, and then the water in the solution or a salt solution gets easily converted into water vapor, and the salt particles are left out in the beaker. Okay, so this is how you use the evaporation technique to separate a salt from its salt solution. So now let us take another example. You can see here what we are doing is we are trying to separate a dye from ink. Okay, so what is ink? Ink is a combination of dye plus water, which is a dye is nothing but it's a color component which is dissolved in a water, and thus it imparts, the dye imparts color, right? So this ink is a combination of dye and water. Dye is dissolved in water. So now how can we obtain this dye from water, from its from its solvent? Okay, again we can use the process of evaporation to extract or to separate a dye from its liquid, is nothing but a water, right? So but we can't use the process of evaporation directly, in the sense we can't supply heat directly to the ink in order to obtain a dye from its solution. Okay, so we have to use this evaporation technique very wisely to separate dye from the water. Okay, so what we are doing is, you can see that we are providing the heat indirectly, right? So you can see that the heat is being given to this beaker which is containing the water, right? We are making this water to boil, right? And then whatever the water vapor we are obtaining, right? So this is nothing but a water vapor. Okay, so when you heat the water vapor is produced. So this water vapor is used to heat this ink. Okay, so what happens? Eventually the water, right, the water content in the ink mixture will evaporate slowly, and the dye, which is nothing but a color component, is left out in the watch glass itself. Okay, so hope you understood this process of evaporations, like when to use. Remember that when a solute is non-volatile and when a solvent is volatile, we can use the process of evaporation. So now let us discuss about the second separation technique, which is centrifugation. Okay, so before going to that in depth, let me tell you when we can use this process of centrifugation. Okay, see, sometimes it happens the solid or the solute particles are very fine or very small that they they escape from the filter paper itself. In such conditions, in order to separate the individual components of very minute or a very fine solute particles, we can use the technique of centrifugation. Okay, so what is the principle which is followed by this? What happens is, the denser particles, okay, the denser particles will settle at the bottom, okay, and the lighter particles will settle at the top when spun rapidly. Like when you spun very rapidly this mixture, okay, what happens? The denser particles will settle at a bottom and lighter particles will settle at a top. So based on the difference in the densities, okay, we are able to separate the constituents or individual constituents from a mixture. Okay, for example, you must have seen your mom how she prepares butter from a curd. What she does, she just churns it so that the lighter particles, the fat, right, the fat molecules are very lighter, right? So what happens when she spun or when she churns it, the fat molecules will be settled in the top, and whatever the heavy content or a heavy liquid content will be there, it will be settled at the bottom. So nothing but your buttermilk, right? So this is how the centrifugation techniques are used. So coming to the applications of the centrifugation technique is used in many places, like in hospitals or the laboratories. Centrifugation technique is used for blood test and urine test, okay, and in dairies and at homes it is used to separate butter from cream, okay, and also it is also used in the washing machines to squeeze out the water from the wet cloths, okay. When the washing machine, when it spins very rapidly, what happens, the water will be removed from the wet cloths, okay. So this is how the centrifugation techniques is being used. Fine, so hope you understood this. So now let us move to the next separation technique, which is how we can separate a mixture of two immiscible liquids. Yes, okay. So now let us discuss how to separate a mixture of two immiscible liquids. So before that, what is the meaning of this immiscible? Immiscible is nothing but it's a mixture, right, where when you mix two or more different components, it won't mix thoroughly, right, it won't form a homogeneous mixture. You will be able to differentiate, right, between the components of that mixture. So such kind of mixtures are called as immiscible mixtures. So here in this case we are going to separate a mixture of immiscible liquids. For example, you can take an example of oil and water, right? So when you mix oil and water, what happens? You will be easily able to differentiate between oil and water, right? So now how can we separate the individual components of such mixture? Okay, so we use a separating funnel to separate the components of this immiscible liquids. So you can see this is how the separating funnel looks like. All you have to do is just put the mixture of oil and water or whatever the mixture of immiscible liquids, you just pour the content into this separating funnel. Okay, so now let it stand for some time. Don't disturb this separating funnel. So after some time you will be able to see the layers are formed, different layers of the constituent particles are produced. So here you can see that the two different layers are formed, right? So one is a water layer is still here, and then oil is formed on top of the water. Correct? So the principle of this, the separating funnel is that these immiscible liquids can be separated or they separate out in different layers based on the densities. Okay, so you know that oil is very much lighter than water, so that's why its layer is formed on top of water. So now how can you separate these two? It is easy, right, because already the different layers are formed. So just open this top cork, okay, and just allow this water to move out from this separating funnel. You can collect it in some beaker, and then you stop this stop cork when the oil layer reaches the end of the funnel. Okay, so this is how you can easily separate oil from water, from the immiscible liquids. Okay, so hope you understood this about separating funnel. So now let us move to the next separation technique, which is sublimation. Yes. Okay. So now let us discuss how to separate a mixture of salt from NH4Cl, or there is a mixture of salt and NH4Cl. How do you separate these two components from each other? Okay, so as you all know that this NH4Cl, which is a ammonium chloride, is a sublimable substance. So what is the meaning of sublimable? Right, so sublimable substance are nothing but which can be easily converted from solid to vapor state directly without going into the liquid state, or from vapor state to solid state directly. If they are converting without going to other intermediate states, we call that substance as a sublimable substance. Okay, so NH4Cl is one such substance and it is being mixed with the salt now. So how do you separate? It's very simple, that you can use the process called as sublimation, right? So what happens in this process? The sublimable particles, right? You can see this arrangement, right? What is happening when we supply the heat and the mixture is kept in this china dish. Okay, so this is a mixture of salt and NH4Cl. We have taken that in a china dish and then we are supplying a heat. So what happens? As you know that when heat is supplied, the sublimable particle, which is your ammonium chloride, right, it directly converts from its solid state to vapor state, okay, and it starts collecting in this inverted funnel, okay, and after some time it solidifies. Okay, this vapors gets condensed, so you can obtain a NH4Cl in its solid form. Here on the edges of this inverted funnel you can see the deposited ammonium chloride. Okay, you can also see that we have kept a cotton plug over here in order to prevent the escape of this NH4Cl vapors from this funnel. Okay, so this is what we do in order to separate NH4Cl from a salt. So what happens when this NH4Cl is converted into vapor state and then it is solidified, right? You can collect that, right, and then whatever it is left out in the china dish is your salt particles, right? So this is how you can use this technique of sublimation when you have one sublimable particle and another non-sublimable particle. Okay, so here sublimable particle was your NH4Cl and non-sublimable particle was your salt, right? So thus you are able to separate these two components with the process of sublimation, right? Hope you understood the separation technique. Now let us move to the another separation technique of chromatography. Yes. Okay, so now let us discuss about how to separate a different color particles from a dye. Okay, so we use a technique called as chromatography. See, chroma, right? Chroma in Greek, this word is derived from a Greek word called as chroma. Chroma refers to what? Color. So as this technique was used to separate color components, okay, so the name was given as chromatography. Okay, so what do you think? Is the dye in black ink a single color? So we will find out that using this technique of chromatography. All you have to do is that just take one strip of filter paper and just mark this line using a pencil and also put a drop, okay, of black ink in the center of this region. Fine, and then what you have to do, you just put this inside water containing beaker or glass jar or a small vessel, whatever it is. Okay, just make sure you are placing this drop, okay, containing ink just above the water level, okay, and just leave it undisturbed for some time and note your observations. What happens? So as the water rises up along the filter paper, the water takes up the different colored particles along with it. So as a result, what happens? Different color components will be deposited at different heights. Okay, as I already told that dye, right, dye is a combination of different colors, or it is a mixture of different colors. Okay, so these colors are being separated with the help of this chromatography technique. Okay, you can see that when water rises up, it will be taking along with it different colored particles. So the color component, which is more soluble in water, rises more faster than a solute or than a color particle which is lesser soluble in water. So you got it right. So what happens? The color component, which is more soluble in water, rises faster, and the color component which is less soluble in water rises thereafter, rises later. Okay, so this is how we can separate different colors from a dye. Okay, so this chromatography technique has different applications, that we can use this chromatography to separate pigments, right, from natural colors, and we can use this technique to separate colors from the dye, and also to separate drugs from the blood. We can use this technique of chromatography. Okay, so this is all about chromatography technique. So all you have to remember here is that the more soluble color component rises faster than a less soluble color component, right? So now we can move to the next separation technique, which is distillation. So now let us discuss how we can separate a mixture of two miscible liquids. Okay, so before that I want you to tell the meaning of miscible. So you already know the meaning of immiscible, right? Which is nothing but it forms a heterogeneous mixture. So it is vice versa of it, where the miscible liquids means they'll form the homogeneous mixture. Okay, they'll mix very thoroughly. Okay, for example, we can take a mixture of acetone and water. Okay, I'll explain this process in detail. Okay, so we can separate a mixture of two miscible liquids with the process of distillation. Okay, so you can see this is how the apparatus has been arranged. Okay, you can see that we have taken a mixture of acetone and water. If we mix acetone and water, we can't separate, right? We will not get to know that which is a water particles or which are the acetone particles. They mix very thoroughly, correct? So how can we separate? Yes, with the help of this distillation process. Fine. So you can see that I have taken a mixture of acetone and water in this distillation flask or a round bottom flask. We call it as a distillation flask, as we are using this for a distillation process. Okay, and you can also see that the thermometer has been set up on top of it, correct? We have immersed thermometer inside this distillation flask, okay, to note down the temperature at which the constituent particles will get evaporated. Okay, and then you can also see that we have a condenser over here, right, and also a beaker. Fine. So how we can separate the mixture? So you just heat the mixture and you can see that eventually the acetone, okay, the acetone which has less boiling point than, it has got a less boiling point than water. Okay, what is the boiling point of water? It is 100 degrees Celsius, right? So but acetone has got lesser than 100 degrees Celsius. So what happens? It evaporates first. Okay, you can also note down the temperature at which it gets evaporated. Fine. So when it evaporates, it will be passed through this condenser, thus it cools down and it can be collected in the beaker. So acetone or a condensed acetone can be collected here in this beaker, and whatever it is left out in your distillation flask is the water. Correct? So this is how you can separate a mixture of two miscible liquids, and also that this distillation process can be used when two liquids can boil, okay, without getting decomposed, and also there should be, you know, sufficient difference in their boiling points. Like here you can see that, right? Water had 100 degrees Celsius, and what is the boiling point of acetone? It is around 50 degrees Celsius, right? You can see the difference between this, right? Almost half. The difference, I mean the boiling point difference between water and acetone is almost 50 degrees Celsius. So there is a sufficient difference in their boiling points, so we can separate them easily. But what if the difference in boiling points of the constituent of the mixtures is lesser than 25 K or 25 Kelvin? So in such conditions we use another technique, okay, called as fractional distillation. It is similar to the normal distillation process, but one extra setup is there, which is nothing but a fractionating column, okay, and rest all remains the same as how it was for a distillation process. process, right? Only extra thing you can notice is the arrangement of the fractionating column. Okay, so what is this fractionating column? This simple fractionating column, it is nothing but a glass tube which is packed with the glass beads. These are all glass beads. Okay. So what this does, this fractionating column, it will provide a surface for vapors to cool and condense. Okay, so that is how we can separate constituent of the mixtures in which the difference in boiling point is lesser than 25 Kelvin. Okay, so we can take an example of hair. Okay, so this hair is a homogeneous mixture of many gases. You all know that, right? And those gases will be having very fine difference in their boiling points. So those gases can be separated easily with the help of this fractional distillation process. Okay, and also to separate different petroleum products, okay, from the petroleum, we can use this fractional distillation. Okay, so now let us discuss how can we separate the different gases from the hair, okay, with the help of this fractional distillation process. Fine. So now let us discuss that how we can separate different gases from hair. Okay, so our motto now is to obtain a oxygen from a mixture of gases, which is nothing but your hair. So for that, what we are doing, you already know that the fractional distillation process can be applied or can be applicable to separate a mixture of two miscible liquids. Correct? So now what we are doing is we are converting this air into a liquid air by increasing the pressure. Okay, so the air is put under high pressure, so that what happens, the hot air is formed and also it gets liquefied. Okay, and this hot air is being sent, okay, through this coolant. We want cold liquefied air. Okay, for that process what we are doing is we are sending this hot air through this coolant. Okay, so here you can see water is taken in and taken out. So when the air is passed through this coolant, it gets cooled, right? And this cooled and liquefied air is being sent through the separator as well as this fractional distillation column. So this is very important for us, right? So what happens here is, see, I have already written that in fractionating column or fractional distillation column, what happens, the gases gets separated based on their boiling points, right? This we already discussed it. Correct. So here you can notice that oxygen is having higher boiling point than argon and nitrogen. Correct. So the least boiling point is nitrogen, which is minus 196 degrees Celsius. Correct. So now what happens, this nitrogen will be collected first. Correct. So this gets separated first. I mean, based on the difference in the boiling points, the gases will be collected at different heights. Correct. So here you can see that nitrogen is being collected at the top, followed by argon and then oxygen, as oxygen is having higher boiling point compared to argon and neon. It gets separated at last. Okay, so this liquid oxygen can be collected in a beaker because you were trying to separate oxygen only from the mixture of these gases, right? And you can also notice here, if you notice the difference between oxygen and argon, how much it is having minus 186 and it is having minus 183. Correct. So if you see, the difference in their boiling point is how much, 3 degrees Celsius. And also if you see here, between nitrogen and argon, it is 10 degrees Celsius. Correct. So in such cases only where the difference in the boiling points between the constituents of a mixture, if it was lesser than 25 Kelvin, we started using this fractional distillation technique. Correct. Hope you understood that how to separate different gases from air, which is a mixture of so many gases. Okay, so that's all about this fractional distillation technique. So now we can go for the next separation technique, which is a crystallization process. So now let us discuss about crystallization process. Okay, this is one of the separation techniques where we use to separate a pure solid forms from its own impure solution. Okay. For example, here we can take a copper sulfate solution in its impure form. Okay, we have a solution of copper sulfate. Okay, now how can you separate a pure copper sulfate solute or a copper sulfate component from its impure solution? Solution means copper sulfate we have mixed in a water. Okay, we have. So now we have the solution, and now what we are doing is we are just heating it out, and most importantly we have to take a saturated impure solution of copper sulfate, because saturated solution is nothing but it's a solution wherein which it cannot dissolve further solute in it. Okay, so such kind of solution you call it as a saturated solution. Fine, so you have taken a saturated impure copper sulfate solution. So now what you are doing, you are just heating it out. Okay, after some time, after heating, you allow it to cool down. Okay, eventually you can see the crystals coming out of this solution and they'll be deposited here. Okay, these are the pure copper sulfate crystals. Fine, so this is how you can use the process of crystallization to purify the solids. Okay, and we also have advantage of this crystallization. It is actually better than evaporation, because some solids, right, when you keep on heating it more, it will decompose. So suppose if you start heating sugar and if you supply more and more heat, what happens? It turns into a black color, correct? It becomes charred, right? And here also sometimes it happens that impurities will remain even after filtration. Okay, in such process what happens? It will contaminate the solid if you try to evaporate such mixture, right? So in these cases, if you see, the crystallization is very much better than evaporation. This technique can also be used to purify the salt which we get from the seawater. Okay, the same crystallization process can be utilized to obtain a pure salt. Okay, so this is all about a crystallization process. Fine, hope you have understood it. So thus, depending upon the nature of the the substances or the constituent elements, we can choose any of these techniques to separate the individual components from its mixture. Okay, so now let us discuss what are the techniques which are used to purify the water. Okay, see, you can see that I have written a diagram where the water is being taken or drawn from the reservoir, right, and then it is allowed to move inside the sedimentation tank. So what happens in sedimentation tank? You can see that it will allow the solids to settle down. Okay, and then the rest of the water is allowed to move inside this loading tank. Okay, so in loading tank what happens? It will again help to sediment the suspended impurities. Okay, all the suspended impurities will settle down in this loading tank. So after that what happens? From this loading tank the water will be transferred to this filtration tank, where actually the filtration happens. Like if there is a fine sand or a gravel or coarse gravel, everything it gets settled over here in the down, okay, in the bottom of this filtration tank, and then the water which is left out here, which is being obtained after the settling of these many components, correct, or these many impurities, this water is allowed to move inside this chlorination tank. Okay, so what happens here in the chlorination tank? It will be added, the water is added with the chlorine so that it helps to kill the germs if it is present, and then this water is directly sent to the different homes. So these are the different techniques what we use in the purification of water. Okay, yes, so that's all about the separation techniques and about this chapter is matter around us. pure. Okay, so hope you understood this complete chapter. If you have any doubts, please drop them in a comment section. I'll try to answer them. Fine. So please like, share and subscribe to our channel, and do not forget to press the bell icon. Okay, and if you are having any exams, all the best for it. Jai Hind. Thank you.